In this video, we're continuing topic 5.6, and we're going to look at example 5. So the graph of f prime is above. They find the intervals where f of x is concave up and down, and find any x values where f of x has a point of inflection. So when we talked about this with increasing and decreasing, we always found our critical numbers by looking at the zeros. However, we're still given the first derivative graph, but I need to figure out whether the second derivative has zeros. So the second derivative has zeros where the first derivative has a horizontal tangent. So we're going to look at, so let me write that down. So second derivative has zeros where the first derivative has a horizontal tangent or a slope of 0, right? So I'm going to look on my graph for a slope of 0. So that occurs at x equals 1. So that is really the first thing. Well, that's going to be our critical number is at x equals 1. So I'm going to use that as my number in my sign chart, and it only has 1 this time. So I'm going to look at my intervals. I know I've got arrows, so I know I'm going from negative infinity. My first fence would be at 1, and then it goes to positive infinity. I don't need the x values because I've got a graph this time. So I'm going to look at what's going on with the, I'm going to look at what's going on with the first derivative and then what's going on with what that means for the second derivative, and then look at what's going on with the original, okay? So the first derivative is increasing. So notice I talked about it being increasing. So that means my second derivative is positive. So my first derivative is increasing, my second derivative is positive. It's a shift in thinking from above below, okay? On this interval, my second derivative is my first derivative is decreasing, meaning my second derivative is negative. So we know that when the second derivative is positive, the original function is concave up. We know when this first derivative or second derivative is negative, we know the original is concave down. So we are going to write this down. The reasons are just a little bit different, okay? Because we're based on the information we have, which is the first derivative. So we would say that f is concave up on negative infinity to 1 because technically the information we started with was f prime. So that's what we have to base our answer off of. Because f prime is increasing, and to be safe, we could say, and f double prime is greater than 0 on this interval. Then we're going to say f is concave down. Again, you want to write these words actually out on the AP test on 1 to infinity because f prime is, again, looking at this row, decreasing. And f double prime is less than 0 on this interval. And then we're going to talk about the point of inflection, which there's definitely a sign change at 1. So f has a point of inflection at x equals 1 because, and again, you have to go back to the first derivative. So because f prime changes from increasing to decreasing at this value, because your explanation has to be based on what you're originally given.